So in this video we will take numerical on non-correlated cash flow, okay, for using Hillier model, non-correlated cash flow. Okay, so a project with initial investment of 100 lakh II is given, lifespan of 4 years, and the probabilistic outcome of different year is given in the table. Year 1, we have net cash flow of 50 lakhs with the probability of 20%, 30 lakhs probability of 50%, and 10 lakhs with the probability of 30%. Okay, similarly for the year 2, net cash flow and probabilities is given for year 3 and year 4. Now we need to determine the expected NPV and standard deviation. We know NPV and standard deviation. Also determine the probability of positive NPV of 30 lakhs, X is given 30 lakhs, and loss. And one more parameter is given, that is discounting factor of 10%. Okay, that is 10 divided by 100, 0.1. Okay. Yes. In the next slide we can see, first we have to determine the expected cash flow. Expected cash flow. Okay, so we will calculate it for the first year. How? 50, or how much probability is given? 20%, that is 0.2. So 50 multiplied by 20% plus this 30 multiplied by 50% plus this 10 multiplied by 30%. Okay, so when we solve it, or I can simplify it also, 50 multiplied by 0.2 plus 30 multiplied by 0.5 plus 10 multiplied by 0.3, and when we solve this we will get 28 lakhs. Values, the unit is given here, lakhs. Okay, similarly cash flow of second year, 60 multiplied by 0.25 plus 40 multiplied by 0.5 plus 10 multiplied by 0.25, and this will be 37.5. Similarly, we can calculate the formula for third year and fourth year. We have to notice one thing, that it is negative minus 10. So here we have to take this negative minus 10 multiplied by 10%, that is 0.1. Okay, it is a loss here. So once we get the expected cash flow of all the 4 years, that is expected cash flow of 1 year, expected cash flow of second year, third year, and fourth year. Okay, then we will calculate the NPV. How NPV will come? We will divide, we know the formula, cash flow divided by 1 plus discounting factor to the power t. Simple formula is there. Okay, so cash flow of the first year is 28 lakhs divided by 1 plus discounting factor 10%, that is 0.1, and this will be for 28 divided by 1.1. Similarly for the second year, what is the value? 37.5. Okay, so we will divide 37.5 divided by discounting factor, or it is for the second year, so we will take square here. For the third year, 47 value is there, so we are taking divided by 1.1, cube 43 divided by 1.1 to the power 4. Okay, and we will subtract all this summation value from, we will subtract initial investment from this value. Okay, initial investment of 100 lakhs is given in the question, and when we will solve this, we will get the NPV of the project. Okay, now next step is that we have to calculate the standard deviation, and we all know that for uncorrelated cash flow, we use sigma square. Okay, as sigma square gives the area of dispersion. So here it is written here, sigma square is written here. Okay, here sigma square is equal to, कैसे निकालेंगे? See, first is 20% probability is given. ठीक है, किसकी? 50 की, और उसको हम सब्ट्रैक्ट किससे कर रहे हैं? जो हमारी नेट प्रेजेंट वैल्यू आई है, दिस वन, है ना? तो स्टार्ट राइटिंग इट फॉर द फर्स्ट ईयर. Probability is 20%, that is 0.2. Here this one, bracket में 50 cash, net cash flow is there, that is 50 minus expected cash flow is given 28. Okay, and we will square it, plus this 50 probability is given, so 0.5, 30 probability of 50 is what? 30. So 30 I have written here, minus expected cash flow is 28 square, plus 30% of 10 lakh minus 28 square. When we will solve it, we will get 196. Okay, so this is the sigma 1, and we can remember this formula, sigma square as probability multiplied by northeast. You can remember with this, net cash flow minus expected cash flow, or summation. Okay, here we have taken net cash flow, expected cash flow, net cash flow, expected cash flow, net cash flow, expected cash flow. This projected cash flow is also known as expected, what we are expecting with this probability. Okay, okay, similarly we can calculate the sigma 2 square, okay, sigma 3 square, sigma 4 square, okay, by using this formula. Okay, the value of all sigma square is given here. Then we will calculate the deviation, standard deviation of NPV value. It is here. Okay, NPV value sigma. Sigma, we are calculating sigma, and of what? Of NPV. So as we have already discussed, that formula will be sigma square to the power 1 plus I to the power 2t, and we will take root, because we need sigma, not sigma square. 2 is there and root. Okay, when we will put all the values in the formula, sigma 1 square is 196, discounting factor we know 1.1, and it's first year, but the power will be 2. Similarly, the power increase in the multiple of 2 to the power 4, 2 get 4, 6, 8, that is fourth year multiplied by 2, because 2t is there. Okay, so we will divide sigma 1 square, discounting factor, sigma 2 square, sigma 3 square, sigma 4 square, divided by discounting factor to the power 2t. That is why we are getting 2, 4, 6, 8 here. And then we will solve it, we will get it 27.86. Next, what was asked in the question? The probability of positive NPV of 30 lakhs. Okay, so we know Z formula is equal to x minus mu divided by sigma. What is the x value? That is 30 lakhs. We have to calculate 30 lakhs. On 30 lakhs mean value, we have calculated in the previous slide also. This one, 21.13 NPV value. Here it is mean value. So we will subtract it from the 30, and we will divide the whole value from the sigma. What is sigma? We have calculated here, 27.86. So value will be, Z value will be 0.318. And now we will identify the area under this Z value and calculate the probability percentage, 37.53. Similarly, probability of loss, x value is 0 here. Okay, mu value is mean 21.13. Okay, and sigma value is 27.86. So we will solve and get the value of z, and area under curve will be 22.42%. मतलब यहाँ पे probability of loss बहुत कम है, 22.42%. Okay, this and this video. Thank you so much.